Okay, as I mentioned, right, this is the topic we are going to discuss now. Okay, if you come to the presentation, see, this is the presentation I have prepared for your people, for you people. You see, okay, if you come to your syllabus, right, actually this IoT analytics is covering in chapter 17, and only one session, first session is sufficient for you. Okay, if you can read 17.1, okay, all these things, that is sufficient, okay, for you. Okay, no need of going in depth, yeah. Okay, I mean, analytics means so much is there. Your actually, you know, your data science is nothing but IoT analytics. Okay, that is a point you have to understand. Actually, this topic is very closely related to your data science. That's the first point you have to understand. Hope you are able to listen me. Okay, if you are if I'm not audible, please let me know. I'm expecting that you are able to, I'm able to audible to you, and you are able to view my screen. Okay, if not, please let me know. Okay, then these are the topics actually under this analytics: introduction, machine learning, advantages of machine learning, challenges and types of machine learning. These are the topics I'm going to cover today. uh, but I'm not going into in depth of any of these things. Just you are a first year students, that's why they have framed the syllabus in a beautiful way. Okay, and only basics, just you have to understand what is what, just what is what. That if you understand that one, that is sufficient for you in your first year. I'm expecting that throughout your 4 years course, you are going to go through all these topics. Okay, that is the point you have to understand. Okay, you are going to be in this complete data analytics throughout your 4 years. Might be once you get the job in your data science stream, I think your life is going to be in this analytics topic only throughout your life. That is the way you have to understand. Okay, now if you come to the analytics, right, what is exactly the analytics? Many times I told you, right, we discussed. Suppose if you take any IoT system, internet of things system, so many sensors will be there. Okay, might be temperature sensor, or okay, so many sensors. I think I had demonstrated you some temperature sensor also, right? One of the thing, yeah. Okay, this is a temperature sensor program we have written. Then we are able to capture the data, right? What is the temperature of that area? We're able to capture that. What that program is doing, simply that is generating the data and giving the data to you. That's it. It's not doing much anything beyond that. Just it is displaying the data every 1 minute. It is measuring the temperature and it is giving to you. Okay, that is data. That is data. With data you cannot do anything. Okay, if you want to use the data, what happened, right, you have to process the data. From that data you have to draw some kind of conclusions, then only that is useful. Okay, here analytics means drawing some kind of conclusions from the available data. That is called analytics. Okay, hope you understand it. So analytics is very very important point and a very crucial point to take the decision. That's the point you have to understand here. The data is available, you have to process the data. From the data you have to derive some kind of patterns, okay, some conclusions, and then based on the patterns or conclusions you can take some kind of decision, some kind of a decision. I mean, something like, if you come to know that, oh, during this summer time temperature will be high, temperature may go this much. Okay, so in that case, you can take a decision whether I had to wear some kind of cotton cloths. Okay, I had to carry umbrella, I had to carry some kind of okay, sun, what is it called, sun cream lotion, something like that, sun cream, something like that. You can, I mean, temperature reading also, yeah, temperature is going up to 50 degrees centigrade. Based on that you can decide to choose to predict, I mean, like, to purchase the product or something like that. For one example I'm telling you, yeah, rain comes. Okay, so what is the climate of today? Yeah, rain might comes, very light rain is coming, then no need of umbrella, just you can go something like that, you can wear some. Okay, you can, I mean, something like that. Might be you can go by two-wheeler, or you can use a public transportation, or you can go by your own car because of the rain is outside. Okay, so much rain is there. Then what about that? Based on that you can decide whether to carry umbrella or whether to carry your raincoat, okay, something like that. What kind of chappals you have to wear? Oh, today rain is going to happen outside. This much rain is going to happen. What kind of chappal I have to wear? Whether shoe is good, whether leather chappal I can wear, okay, or something like that. Okay, you can decide everything, something like that. Hope you understand. Analytics is a very important. Basically, what I'm trying to know, data is there, process the data, derive the conclusions or patterns, and take a decision on that. Okay, that's about analytics. Then, if you come to this IoT based system, okay, we are much, everything is data. Okay, you're counting a vehicles, that is also data. Student marks is a data. Okay, but we are studying about IoT subject, right? IoT subject. So if you come to the IoT subject, what is going to happen? That is going to generate different kind of data. Suppose if you take any IoT system, so for example, if you take a agriculture use case, what happened? So many different kind of sensors are there. Might be temperature sensor, camera sensor, or humidity sensor. Okay, different kind of sensors are there. They generate a different kind of informations. I mean, like, very complicated data that is going to generate. Okay, for that kind of complex data, what happened, right? You had to use very sophisticated data analytics algorithms you have to use. I mean, very specialized algorithms or very specialized data analytics techniques you have to use. That's a point you have to understand here. That means that is a data science subject. Your data science engineering 4 years course is going to teach you all these different data analytics techniques and all. Okay, that is the point you have to understand here. I mean, it's something like that, driving, the driving. Okay, might be when you're driving in a Bangalore road, the different kind of technique you have to use. When you're going in highway, different kind of technique you have to use. When you're in village and all, okay, different kind of, everything is driving only. But what your same car you're driving, okay, but different kind of techniques you have to use. Sometimes car also you have to change. When you're driving in a hill area, you cannot use normal Maruti 800, right? You have to use some kind of very sophisticated car where that four wheels, okay, I mean, like front and I mean, I don't know what it is called. Four wheels can move. Okay, that kind of cars you have to use. Okay, something like that. Okay, based on the situation, based on the requirement, you have to use different kind of data analytics techniques you have to use. That's the point you have to understand. If you come to the analytics, actually how the flow will be, there is a data. The data will be stored in somewhere, and then you have to filter the data. I told you, right? Sometimes data will be there. You have to make it is some kind of good structure. You have to filter it. And you have to segregate the data. Okay, and you have to make it ready to use for your data analysis. Then you have to apply some kind of data analysis techniques. Data analysis techniques might be different ways. Difference are there. Okay, then what happened, right? You have to derive some kind of patterns, conclusions. Then based on these patterns and conclusions, you can take a decision on that. Here, if you see data analytic technique, simple technique is an Excel. I have shown you, right, in one of the temperature case. What happened, right? Temperature readings are coming. I try to draw one kind of graph, right? Graph is showing how the temperature is moving. Okay, up, down, how much variation is happening. It was showing. That is a very basic data analytics technique, that one. That is a very simple one. But if data is more complicated, you have to use different kind of languages, different kind of algorithms. Okay, all these things you are going to study in your data science engineering during your 4-year course. Okay, is it possible simple programming languages? Yeah, actually what happened, right? As I mentioned to you, if the data is very simple, only one sensor is giving a kind of, some kind of digital reading or analog reading. Okay, simple techniques are fine. If the data is more complicated, you have to use a very complicated algorithms, very complicated programming skills you have to use. Okay, hope you understand that one. Okay, uh, okay, here I'm telling to you, yes, so many tools you have to use, so many other tools are available. Okay, these tools like k-means and discrete tree, random forest, okay, k nearest neighbor, okay, density based spatial clustering applications. I mean, these are the different kind of algorithms are available, already defined, tested, proved, okay, for each kind of problem. Okay, so many are there, you no need to dive into those things now. Okay, that is a part of machine learning actually. Okay, just you have to understand that, oh, so many algorithms are there. Okay, these algorithms we can use for processing the data. That is the point, you have to understand that one. Okay, hope you are getting that one. Okay, so many algorithms are available. Okay, don't get into that one now. Okay, then if you come to the machine learning. Okay, what is this machine learning? Okay, we are going to see that one. What is this machine learning? See here, actually this machine learning, first it was coined by Arthur Lee Samuel in 1959. The machine learning, the word is coined in 1959. Okay, now we are seeing the results of that one. Okay, see, if you see, this machine learning is a powerful tool that allow computer to learn from past experiences. Okay, machine learning means what happened, right? There is a data is available, there is data is available, okay, to process the data, and uh, it it uses not only the current information, it uses the previous informations, and then it will take some kind of decisions actually. This is called machine learning. That means here what I can say, machine learning in generally uh, giving a kind of intelligence to the system here, giving a kind of intelligence to the system. Actually here what we are doing, uh, I mean, it's something like, it's not like I can say kind of human being, but here what happened, right? In processing the data, in processing the data, it uses previous results, past experiences, faster experiences. Okay, and it automatically improves of its capabilities. I mean, something like that, suppose today you want to go to the college at 9 o'clock. You want to go to the college at 9 o'clock. Okay, then what about you started from your home at 8 o'clock. Okay, 8 o'clock. You reached your college by 9:30, 30 minutes late today. Then what happened? Tomorrow what you will do? Tomorrow what you will do? What you will do? You try to leave by 30 minutes early, right? What again? Tomorrow you will leave by 7:30. 7:30. Okay, then you might reach by 9 o'clock. Suppose by if you leave by 7:30 also, if you reach by 9:15, then what you will do? That is one more learning for you. You try to leave your home by 6:45, something like that. Okay, this is called machine learning. Okay, then actually if we come to this machine learning, what happened, right? See how it works is, it uses the fast data, learning from the fast, and predict the output. This is the thing I'm telling you. Okay, it uses the present data and fast data, fast learnings it uses, and it will generate the output. This is called machine learning. Okay, hope you understand what is the machine learning actually means. Okay, I mean, it is not only use the present data, it uses the past past learnings, and it will track a decisions. This is called a machine learning. Okay, now I'm not going to cover this advantage and all challenges. I will move to the advantage and challenge at the end of this presentation.
Excuse me, sir.
Yeah, yeah, please tell me. Yeah.
Sir, many wants to join. Please allow them.
Oh, really? Okay. How to admit, all right. Okay. Okay, how machine learning works means, like, it uses the fast data, learns from the fast, and predicts the output. This is called machine learning. Okay, then if you come to this machine learning, Okay, to understand machine learning, okay, you have to understand some more things also: deep learning, machine learning, and artificial intelligence. Okay, here actually what happened, right? If you come to the IoT analysis, IoT analysis, anyone is joining? Oh, okay, if you come to the IoT analytics, right? If you come to the IoT analytics, if you come to the IoT analytics, exactly what is happening here is, if you come to the IoT analytics, what I'm trying to tell you, know, there is a data is there, processing the data, and you are finding the results to take a decision, to take the decision, to take the decision. Okay, to take the decision. Here, in the process of taking all the decision, okay, machine learning is a very important thing. Machine learning is a very important thing, and this is covering in your syllabus. Okay, remaining not, or not covering in your syllabus. Okay, but that's why we are studying about only machine learning. But if you want to understand this machine learning, you have to understand about three things. One is deep learning, another one is machine learning, and then artificial intelligence. Okay, here deep learning means actually there is a data will be there. Okay, data. Okay, here what this, in this deep learning, what happened, right? Actually, the output of deep learning is used by the machine learning here. Okay, actually what this deep learning will be doing is, actually deep learning is a part of machine learning. Deep learning is a part of a machine learning, and the output of the deep learning is fed to the machine learning. Actually you can say it's a machine learning only. In this, what happened, right, in the, as part of deep learning, what we are doing, you know, there will be so much data is available. There is so much data is available. What happened, right, by using some kind of techniques, deep learning algorithms, deep learning algorithms, what we are doing, you know, we are structuring the data. We are structuring the data in a usable format. In usable format. Okay, in usable format, I mean, it takes, deep learning techniques are, deep learning techniques allows you to process so much data, so much data, and that will structure the data in such a way useful for to the machine learning programs or machine learning algorithms. I mean, one example I'm telling you, just I'm telling you, you know, uh, actually here deep learning uses the artificial neural network techniques. Actually, I mean, actually how our brain works, this is the way how our brain works. For example, assume one of the thing I'm going to tell you now. See, assume there is a eagle. Eagle is wandering in the sky. Okay, it is wandering in the sky. Okay, it is wandering in the sky. What it will do, you know, if it finds any prey on the road, somewhere on the ground, I think might be you will be watching so many videos, right? Okay, if it is wandering on the on the sea, assume on the sea wandering. Okay, if any fish is going in the water, what happened, right? Quickly dives, okay, towards the fish, and it catches the fish and it runs away, right? That is the way. Okay, see what happened, right? See how that eagle's brain works there. Eagle's brain works there, right? That is doing lot of deep learning techniques that is using at the time. What happened, right? Actually, you know, many people developed the algorithms by inspired from that eagles. Really, what happened, right? How it observes the prey, then it dives. Actually, it calculates. The fish is not idle, right? It is fish also wandering in the water. Fish also wandering in the water. Then what happened, right? The eagle, what it will do? It will calculate how much is the distance, with what kind of angle it has to come, and what kind of speed it has to maintain. Okay, and how to catch that fish, how to catch that fish, how to run away from that. Okay, see all these things, right? This is the called data mean, like, you know, it calculates everything, it calculates everything data, and it calculates in such a way, it structures the data in such a way, and it will take a decision how it comes and all. Okay, this is called deep learning techniques. Mainly deep learning techniques are used to process the large volumes of data, and keep in a different structures. I mean, actually, that eagle calculates everything. How much distance will be there? Okay, how this fish is wandering, and it calculates all the data. Okay, how it is moving and all, whether it is circulating or it is going in right direction, left direction. Okay, everything it calculates, and it try to arranges all the data in a proper structures and all. Then it uses all the data to catch the fish actually. I hope you're understanding. Here, what you have to understand, deep learning techniques are used to process a enormous data or enormous different kind of data and make it in a some kind of usable format. Okay, based on that, right? And it uses the techniques again. What about it? Then next machine learning will come. Okay, the data is available, and machine learning. What about it? The eagle uses the fast experiences. Sometimes it would have been measured some fish also. Every time it cannot catch the fish, right? And it thinks, oh, last time yesterday I was not able to catch the fish. Okay, and it uses that kind of information, and it uses all this data, and it will try to capture the fish actually. That is the machine learning actually. Okay, hope you're understanding. Okay, that is the way it works actually. What you have to understand is deep learning is to process the data. Okay, machine learning is that uses the current data and actually previous experiences of that eagle, okay, to catch that fish. Okay, and sometimes actually again artificial intelligence means, okay, now what happened, right? Deep learning, so data is available, processed data is available, machine learning fast experiences are available. Okay, then based on these things, right, artificial will decide, I mean the eagle will decide whether to catch the fish or not. That is the thing. Okay, ability to machine to you, okay, initiate the intelligence human, imitate the human behavior. I mean something like that. You will take a decision again on the top of that one. It will take some kind of a decision actually. Okay, I mean like mm, might be it can change. It can, might be it will wait for some more time. I mean like it will wait for some more time, might be to catch the fish, or immediately to catch the fish. Okay, or it has to try for some other prey, something like that. Okay, that artificial intelligence allow you to take a decision here. Okay, hope you are understanding. Okay, deep learning is related to the process, I mean data processing. Okay, machine learning is some kind of algorithms, uses the previous experiences and current information. Okay, it will create some kind of analytics. It'll give some kind of information, it gives some kind of decisions. Okay, based on that decisions, right? Okay, then I mean like based on the analysis, machine learning generates the analysis actually by looking into the current data and the previous experiences. Machine learning gives some kind of analysis. Based on that analysis, right, our brain will take a decision. Okay, might be that's called artificial intelligence. Okay, that is the link between deep learning, machine learning, and artificial intelligence. These three things gives the ultimate results. But if we come to your syllabus, you are having only some introduction about only this one. What I can say, what is this? Where is, no one is there. Okay, it will give some kind of a decision. I mean like uh, all three together will give some kind of decision making capability to some system. Okay, that's the point you have to understand. Okay, so this is about data, deep learning. If you come to the machine learning, okay, computer science that uses the computer algorithms analytics to build predictive models that can solve the problems. Okay, the main goal of artificial intelligence is to develop a self-reliant machines that can think, act like humans. Okay, something like that. Okay, data processing, and by using data processing and previous experiences, machine learning will generate some algorithm, like some analysis, analytics and all. Based on that, okay, the machines will take some kind of decision. Okay, if they're able to take the decision, that is called artificial intelligence. It's all like human being. You can say all our human beings having all these things. We are having a capability of data processing. Okay, we can process the structured data or unstructured data, anything. And our we have a machine learning techniques inside that. We know past experiences, and we can use the current data. Even we can predict the future experiences, future things. Okay, and based on that we can take a kind of decisions. Decisions whether to go or wait or finish or delay, something like that. Okay, we have all these things. Basically what we are trying to do, we are trying to mimic the human behavior, human intelligence again. Okay, that is just we are reinventing, that's it. Nothing, we are not doing anything. We are trying to reinventing, and we are trying to give these capabilities to the machines. That's only the thing you have to understand. Okay, then if you come to this machine learning, there are four kinds of machine learning techniques are available. Okay, that is called machine supervised learning, unsupervised learning, semi supervised learning, and reinforced uh, learning. These are the four kind of different kind of machine learning techniques are available. Okay, we are going to see one by one what is the supervised. First I will tell you about this is a very famous one, supervised and unsupervised. What is the difference between supervised learning and unsupervised learning? Okay, suppose if you take supervised learning, right, it is a kind of thing, where input is available. So we are giving input, and we know what to find. We know what to find. What is the, I mean, like actually if you take this thing, what happened, we'll be giving both input and output. What we have to find also we are giving to the problem, and that problem has to identify what is that output is, what is that output is. Okay, then if you come to this I'm going to explain you in detail. Okay, unsupervised learning, only input data is available, there is no output data is available. Okay, output is not there, we don't know what is output, but the problem has to tell what is that output is. Okay, I'm going to tell you that one. First, something what you have to understand, there are four kind of machine learning techniques are there. Okay, supervised, unsupervised, semi supervised, and reinforced. For difference between supervised and unsupervised is, in supervised technique, input and output both are defined. Input and output both are defined. In unsupervised, only input is, no output is defined, but you have to get the output. We are going to see that one, how it is. Okay, we don't know output in that one. Okay, now, okay, and here, first of all, okay, these are the four things. Just I'm going to show the differences here. Again, we can come back also, no problem. Okay, here, what about the first go to the supervised learning? Anyway, I will come back to this one later. If you come to the supervised learning, what happened right here? Uh, just assume there is an example here. I have taken this example from one of the website. Okay, this is the your data machine learning algorithm and data processing everything. Then here, what happened right? Initially, you are providing the inputs to the program. That means you are giving so many inputs, what happened right? Cat, rat, dog, these three things, assume cat, rat, dog. Okay, these three you are giving to the program, and you are asking find the cat, find the cat. Okay, here what happened right? Already in your program you defined what is cat, what is rat, what is a dog. Okay, already all this data is available inside in a database, inside the database. Now you are giving a question to this one. You are giving, you know you are giving you are giving a cat image or dog image. Assume in this case we are giving a dog image to the program. Okay, and telling, you are asking your program find out what is this thing. I mean, in your school, right? What is something like this? Already as a teacher, for the student, right? Teacher is showing, hey, this is apple, this is mango, this is orange. Okay, these three things she kept there. She kept there. Orange, mango, apple. These three things she kept in one hand. She is showing to the students. Okay, apple, mango, orange. Apple, mango, orange. She is showing to the students like this. And in one more hand, she's taking an apple and is asking, what is this? Then students will tell apple, mango, orange. What is this thing like that? Hope you're understanding. Okay, in your program you are feeding all the information, all the patterns, and you are giving one new pattern to this thing. You are asking which pattern it is matching. I mean, something like that, as I mentioned, right? Okay, in a basket you are showing to the students apple, mango, banana, apple, mango, banana. Okay, and you are showing a banana to them. Okay, what is this? Then they have to tell, oh, banana, something like that. Okay, this is called supervised learning. That means you have given all the information to them. You have given all the information to the program, and you are asking your program to identify what is that. This is called supervised learning. Okay, here what happened right? Some algorithms. These are the algorithms: linear regression, logistic regression. Okay, these kind of algorithms, Navi based algorithms, so many algorithms, decision tree algorithm. These are the algorithms. These are the machine algorithms in generally people use this kind of supervised learning. Okay, supervised learning. Okay, supervised learning. Okay, then if you come to the unsupervised learning, in the unsupervised learning, right, you are not telling apple, mango, banana, something like that. You are not telling that. You are not telling that. Okay, you brought some kind of fruits. Okay, might be 5 bananas, 4 apples. Okay, you give in a box to the student. You are asking them, hey, segregate them on student. You gave a small task to the student. In that you kept 5 bananas and 5 apples, 5 oranges. Assume 5 bananas, 5 apples, 5 oranges. You kept in a bowl, and you are asking the student or a child, hey, can I identify what is this? Can I identify what is this? Then what the student or child is doing? He is segregating 5 bananas in a one, uh, keeping one place, 5 oranges, 5 oranges, 5 apples, something like that. I mean, here what the child is doing? Child is doing clustering here, clustering here. Okay, clustering here. Just what happened? You are feeding some kind of information, question you are giving. You are giving a bunch of data, and student is clustering, segregating by looking into the features. By looking into the features, right? See here in this example, what happened? He fed so much information, different vehicles information he has given, different so many cars also, right? Okay, if you take uh, Maruti 800, Maruti Wagoner, okay, might be Innova. All these are cars. All these are cars. If you come to the buses, so many different buses will be there, right? Okay, double decker buses, okay, sleeper buses, okay, something like that. Buses will be there. Trains, so many different kind of trains will be there. Like that, you are giving all the information to them, and you are asking your machine level algorithm to segregate or to separate or to identify them. In that case, what that machine learning algorithm is doing, that is segregating them into clusters. Okay, there is no predefined. You are not feeding information to that guy. You are not this is called unsupervised learning. You are not feeding any information to that guy. Just you are giving information, and you are asking them to identify something, take a decision on that one. Okay, that means sometimes wherever you want to do a clustering, you have to go for unsupervised learning. That's very important point you have to understand. Same technique you cannot use to solve all the problems. That's a very important point. As an engineer, you have to understand whether I have to apply a supervised learning technique here or unsupervised learning technique here. If you come to the unsupervised learning algorithms, K means clustering algorithm, hierarchical clustering algorithm, anomaly detection. Okay, these kind of so many, okay, algorithms will be there. Might be as a data science engineer, you also has to predict or develop some kind of algorithms. Okay, if you develop your own algorithms, they are working very good for kind of decision making. Okay, you get money, right? You get patents and all, you get money and all. Okay, hope you understand the difference between supervised learning and unsupervised learning. In the supervised learning, you are feeding all the information, you are feeding everything. You're training that. You're training initially, and then you are asking to take a decision. In unsupervised learning, you are not giving any training. Okay, just you are providing the question to that one. Okay, it is providing the output to you. Okay, hope you're understanding. In general, unsupervised learning will be used for clustering the data. Okay, then if you come to the reinforced algorithm, what happened, right? No input and no output, actually. I mean, here no input, no output means here it is something like that. There is no any predefined data. There is no any predefined data. Okay, something has come, something has come, and it has to process that one. It has to face it. It has to face it, and it has to measure that. It has to measure that. The reward measures how successful the action. I mean, something like that. One example I am giving to you: James Bond finding the way to open the locker. Okay, something like that. Suddenly you experienced some problem, experience some problem. Might be that problem may not appear to you before. Okay, appear to you before. Now only the problem has come. Then by doing trial and error basis, by using trial and error basis, you are going to fix the problem. This is called a reinforcement technique. Hope you're understanding. Mean sometimes when there is no any kind of previous experiences, previous occurrences of that problem, you are going to solve that problem. In that case, you have to use a reinforcement learning techniques. That's the point you have to understand. Okay, that means for your machine, you have to provide all these things. Okay, okay, it's something like that. See, suddenly you identified you are going on the way. Suppose, for example, you are going for trekking. You find some object there. You find some object there. Then you have to process that object. Hey, it might be a circle. You found one object means one stone, big stone. Okay, you have to think this is whether it is what kind of thing it is. Okay, you have to understand everything, and then you have to decide whether it is a circle or a triangle or something like that. Okay, might be some kind of new problem came, and you have to solve this problem. That kind of scenarios you have to use a reinforcement algorithm. Okay, reinforcement learning technique. And the reinforcement learning, also some algorithms are there. These are q learning and deep q learning. Okay, neural network things and all, like these are some algorithms are available. Basically, you have to understand that what is the difference between supervised learning, unsupervised learning, and reinforced learning. Okay, the machine learns by using the labeled data. Labeled data means previously defined data is there. Here, unlabeled data, no previous experience data is there. Here, if you come to this thing, right, see, nothing is available here, nothing is available here. Instantaneously, by using a trial and error basis, it has to decide in the reinforcement learning these things. Okay, and basically what kind of technique we have to use for what kind of problem. Okay, if you come to these classification problems, you have to use a supervised learning. Okay, clustering to divide, group the data and all. Okay, you have to use unsupervised learning. Then if you come to the reinforcement learning, okay, reward based, that means by using a trial and error base, it has to identify the solution. In that case, you have to use a reinforced algorithm. Okay, here labeled data, not labeled data, and no predefined data is available here. Okay, here external supervision, no supervision. Here also no supervision will be. We're not going to supervision in these two cases. But here, what happened? Where means in the supervision case, right? It uses the previous experiences and it remembers that, and it uses that one. Okay, approach. Okay, maps the labeled input to the output. As I told you, right? Already three things are there. It will map to one of the guy and it will take a decision. Okay, in this case, right, it won't map that one. It understand the patterns. Oh, car this much size is there, like this. Might be a banana. Or suppose if you give a lucky banana, like that 4 5 types of bananas, if you give to the program, it will identify that one all together as a banana. Or this is belongs to banana. Might be if you are giving different kind of ladies, gents, short, long, kids and all, everything, it will segregate all these are human beings. If you give cattles, it will segregate that as a cattles. If you provide different kind of birds information, it will cluster that thing as a birds group, something like that. Okay, here in this case, it uses the trial and error method to identify the solution for the problem in a reinforcement learning. Okay, these are the different kind of machine learning techniques are available. For each machine learning technique, right, there are different predefined algorithms also is available. Okay, you can use any one of those things. As for your syllabus, you have to understand only what is different kind of machine learning techniques, and what are the difference between them. Okay, might be just you have to remember some kind of what are the different kind of algorithms. Okay, you have to understand. Then if you come to the advantages of machine learning, advantages of machine learning, right, self learning. Okay, I mean automatically it will take a decision. Okay, time efficient. Yeah, it will take time efficient means quickly it can take the decision. Self guided, yes, it's a self guided. Okay, it will take decision on its own. Okay, and okay, it will drive on on its own. It will drive on its own. That's the point you have to understand. It will drive on its own. Okay, minimum human intervention. Okay, why we are implementing all these things is for the minimum human intervention, something like that, right? Sometimes if you open some chart boards and all. Okay, one example I'm telling you here. Okay, here what happened, right? Not this one. I think, see here, this is a chatbot. This is the kind of, machine learning thing only. Okay, when you log in these things, see here, when I log in this thing, it's a chatbot. Chatbot is a kind of, machine learning thing only. See here, when I log in here, then when I open this page, what it will do immediately, someone will come and it will ask you some kind of information. Oh, it's not coming now. I don't know the reason. Okay, automatically. I think actually this person is not available here. But what happened, right? It is asking. It is asking, you need any help or something like that. This kind of machine learning. Based on your inputs, right? Based on your input, okay, it will give some kind of guidance to you. Okay, some kind of guidance to you. Okay. And diverse data, might be what I'm trying to tell here is diverse data means, it mean you can use this one for different kind of data, different kind of data, mean not only particular kind of data, but different kind of data. Might be one example in our language. Okay, different, I mean, like, uh, machine learning algorithms can use it for temperature sensor data or camera sensors data. Okay, or to drive drones, to drive motor. Okay, might be for multiple purpose. Different diversified data means different kind of data, different kind of data. You have to understand that one. Okay, diverse applications, I mean, we can use these things for diverse applications, right? Even diverse applications means different kind of applications. For example, to drive the car, for agriculture thing, for hospital things and all. Okay, okay, multiple things. Okay, so many advantages are there. Okay, as for your syllabus, these are the things they have mentioned. Okay, you can go through that one, no problem. Just you can go through that one. Okay, then if you come to the challenges, what are the challenges are there? Okay, obviously so many challenges will be there, right? See what happened, right? When you want to use the really fruits of enjoy the fruits of machine learning, so many challenges. Data description. Okay, what happened? Different sensors are required to information and meaningful and describe the data in a challenge. Actually, I mean, actually, what happened? So much. I mean, like, different kind of data will be coming. Okay, and describing the data into a usable format. Okay, and sometimes what happened, right? You want to gather some information, you have to use a kind of, different kind of sensors to gather that information also. Okay, something like that. One time, someone asked me a question, sir, if I want to control a fan and light in my bedroom, can I use same sensor? No, right? For light you have to use one sensor, for fan you have to use or air condition you have to use a different kind of sensors. Okay, that means your machine learning algorithm want to take a decision, you have to use different kind of sensors to get the data. Same sensor data you can use for to control all the applications. Again, both ways it is. When gathering the data, also you have to use correct sensors. Once the sensors are giving the data, you have to bring it to the your usable format. These two things are important. That is called data description. Okay, by using a temperature sensor, if you want to control your lighting, that is kind of meaningless sometimes, meaningless. Okay, that's kind of. Okay, might be motion sensors can be used for to control the light. Temperature sensors information can be used for uh, you know to control the air condition and all, something like that. Okay, and amount of data is also very important. Yeah, I mean, amount of the data means, you don't think it's a large amount of data. Or suppose if you have very small amount of data is available, your decision making is less actually. For example, assume you want to find out whether the one boy or one girl is, you want to assess their character means, don't feel bad, character means what kind of personality he is, whether he is a good person, bad person, or is a workaholic or something like that. If you want to define what happened, right? If you have so much information, you can identify what kind of person he is of. Okay, might be you met him for 1 hour, and if you take a decision about that person, that might be not the right one actually. Might be during that 1 hour time, he or she has given some kind of information to you. Okay, but if you are traveling with him for many days, then you will come to know what kind of personality he is. Okay, that is the point you have to understand here. Hope you are getting my point here. Okay, I mean, that means if you have more information, you can take a better decision. That is the point you have to understand here. Okay, with the small data you cannot take a decision. Okay, might be even for many person, if you meet, right, immediately you may feel he is good because at the time he was talking to you very nice. Or might be he is not that much good or she is not that much good. Okay, sometimes when you meet one person, might be you may feel he is very bad because at the time his mind is not good, at the time his behavior is not good. You may feel that, oh, he's a bad guy. Might be basically might be a good guy, we don't know. Okay, something like that. How much more data you will available, you can take a better decisions. That means for machine learning algorithms to work better, right, you have to have so much data. You have to have so much data. For example, to predict, actually, AccuWeather was telling to me, from last 1 month I was waiting for the rain. Actually, AccuWeather was telling that rain comes in the month of May based on their data they were telling. But yesterday it was rain, right, in Bangalore. Okay, something like that. Okay, okay, that's one of the thing. Might be sometimes, okay, erroneous data. Okay, the data may contain noise and error on these hand. Okay, learning of this model heavy depend upon the quality of the data. Okay, what about, right, misleads the information, error information. Okay, if the data is having, suppose you have so much data, okay, but that is a wrong data, some errors are there in the data, then machine algorithms won't work. Okay, so you have to have some kind of data pre-processing techniques to identify or to correct the data. That is also important. Okay, this is the thing. Selection of the model, as I told you, right, if you come to the machine algorithms, right, there are supervised learnings are there, unsupervised and reinforced, like different models are available. Okay, you have to identify for this kind of problem what kind of a model I can select, supervised or unsupervised or reinforced. You have to identify that one. For that problem you have to apply that technique only. Okay, otherwise what happened, it may not work. It may not work, it may give some different kind of results. Okay, as a data science engineer or AML engineer, that is your duty to apply correct model to your the correct problem. Okay, that is a point you have to understand that. Okay, quality of the model, after selection of the model, is difficult to determine the quality of the selected model. However, the quality of the model is, okay, essential in the uh, ML based system. The quality, I mean, actually what about that again, the data is available. Okay, I have chosen some model and developing some kind of programming here. But what about, right, we don't know what is the quality of the model which I have selected. Might be you have to test that one also. You have to test that one whether that is giving the good results or not. Okay, then you have to decide whether the model is appropriate and whether the model is correctly working for your problem or not. Again, what is going to happen, you cannot say, I mean, that's the one point I'm telling you are here. If you come to this machine learning and artificial intelligence things are, we cannot expect always positive results or success results. There is a point. Okay, it's all like, error and trial. And for this you cannot use the same strategy for every problem. Based on the problem you have to change the strategies, even though, okay, for that particular problem sometimes it may not work, sometimes it may not work. Again you have to reinvent the things and all. You have to fix the things and all, and you have to, every time you have to improve the efficiency of your algorithm or program, and you have to move on. Yeah, this is the way it has to work. Every time you have to, you know what is it called, correct the system. Every time you have to correct the system and you have to improve the system. I mean, it's something like that, our human nature also, right? Suppose what happened, right, we are living. Okay, how we have to live, same like this only. What happened, right, based on the available data, we have to learn the things and all. Okay, if any wrong information is coming, we should not consider the wrong information. You have to know whether to consider the wrong information or not. Sometimes your friends will be giving bad inputs to you, you should not consider them. Or your neighbors are giving bad information, you should not consider them. Okay, and you have to choose the model in what way you have to leave that. And you have to correct your model also. Every day you have to correct yourself and you have to grow yourself, and then only you will become a good person. Okay, suppose if you stop correcting ourselves, then you will become idle. We will become useless again. Every day we have to correct ourselves, we have to gather more information, we have to avoid unnecessary error informations and all. We have to improve our system. Okay, and we have to develop on our own. Okay, this is the ultimate thing I'm trying to tell you. Okay, hope you understand. Okay, all these things. Okay, something like that. It's like this is also something like the way of living, the way of living, you have to understand that one. Okay, hope you understand what are all these things, what are all these things. Okay, Okay, guys, please. Okay, so with this I given some update on what is the data analytics. Okay, and what is this data processing, what is the machine learning. Okay, and what is the difference between deep learning, machine learning, and artificial intelligence. Okay, and types of machine learnings. Okay, and what is the advantages of machine learning, what is the challenges in the machine learning. Okay, my suggestion is just go through this 17th chapter and first 17.1. Okay,
क्या गंदा था क्या
yeah.
गंदा था
Oh, God. Okay, you have any questions, guys? I think I'm planning to stop this thing with us with this. Okay, you let me know if you have any questions or we can go through that. Okay,
क्या गंदा है क्या गंदा है क्या गंदा है क्या गंदा है
Ramakrishnan, who is this? Okay, guys, then okay, take care, then
हाँ
we'll meet up again. Okay, bye for now.